Hi, welcome back to the channel. In this lesson, we'll see how to express complex numbers in exponential form. I want to say a big thank you to our subscribers. We have hit the 500 marks and I'm grateful. I want to say a big thank you. And we are yet to hit the subscribe button. Please do not hesitate to hit the subscribe button. That way, you'll be encouraging us to do more and you'll be telling YouTube you love what we're doing. That said, let's get into it. In our last lesson, we saw how to express complex numbers in polar forms. We said that Z is equals to R in theta, where theta is an angle, and I use the Argand diagram to explain these concepts. Where we marked R, we saw our B as the imaginary part of the Argand diagram, and we saw our A as the real part of the Argand diagram, and we saw R, and we marked theta as our angle in the first quadrant. Now, in case you missed that lesson, please do not hesitate to check this link above. We have included a link to that lesson. And also in the description, we'll place a link to that lesson. Now in this lesson, we'll be seeing that Z is equals to R e raised to power theta I. Now where this is the exponential form. E, obviously we all know that e raised to power x is exponential. That is a way of finding exponential numbers. Now but this time we'll be expressing complex number in exponential form. Now let's prove this. The proof is not too important. You might not have to use this all the time, but having a good knowledge of the proof will help. So let's just go through the proof. Now we know that from our series, we know that e raised to power x is always of the form of 1 plus x raised to power 2 over 2 factorial plus x raised to power 3 over 3 factorial, and the series continues this way. And also for series, we know that cos theta in series form will always come from 1 minus x raised to power 2 over 2 factorial plus x raised to power 4 over 4 factorial minus x raised to power 6 over 6 factorial plus, and the series also continues. It's a series. Now sine theta also will also come from 1 or x, theta in place of, I've been using x here, is theta not x. Sine theta also will come from theta minus theta over 3 factorial plus theta over 5 factorial, that is theta raised to power 3, theta raised to power 5, minus theta raised to power 7 over 7 factorial plus, and the series continues this way. Now, if e raised to power x is in this format, obviously we can now replace x with theta I. Let's replace x with theta I. Theta I, e raised to power theta I becomes 1 plus theta I plus theta I raised to power 2 over 2 factorial plus theta I raised to power 3 over 3 factorial plus theta I raised to power 5, everything here raised to power 5 over 5 factorial. Also here, everything here is raised to power 2, everything here is raised to power 3. Now this series also, it continues this way. Now if you had followed our lesson where we explained multiplication of complex numbers, we said that I now is the same thing as the root of minus 1, and I raised to power 2 will be equals to root of minus 1 times root of minus 1, that's equals to minus 1. I raised to power 3 will be the same thing as I raised to power 2 times I, that will be minus I. And I raised to power 4 will be the same thing as I times I, that will be the same thing as I times I, that's equals to 1. Now we'll use these basics to expand e raised to power theta I further. That will be the same thing as 1 plus theta I, we'll leave that as theta I, plus theta I squared. Now theta will become squared, but this becomes minus because I squared is what? Is minus 1. So this is minus theta squared over 2. Now theta theta I raised to power 3 will be left as I raised to power 3 itself is minus I. So this becomes minus theta I. This is theta raised to power 3. I is left alone without the 3 factorial. Now, plus theta I raised to power 4. Okay, there should be power 4 here before the 5. I omitted theta I raised to power 4 here. That will be plus theta raised to power 4 over 4 factorial. Now theta I raised to power 5 will be theta raised to power 5. Now I, because theta I raised to power 5 is the same thing as theta raised to power 4 times, the same thing as I raised to power 4 times I over 5 factorial plus the series continues. Now let's collect like times, so that e raised to power theta I will be the same thing as 1. Now, those we're going to separate, in collecting like times, we're going to separate those with I from those without I. Now that this becomes 1 minus theta raised to power 2 over 2 plus theta raised to power 4 over 4 factorial. Now the next will be minus theta raised to power 6 over 6 factorial. Then the series continues. Now let's put a bracket here because of my space. Now plus I now will now collect like times for those with I. I have the first with I is theta, so I have theta in here minus theta raised to power 3 over 3 factorial plus theta raised to power 5. You see theta raised to power 5 as an I over 5 factorial. Then the series also it continues. Now so that E now raised to power theta I, you can now easily substitute. If you look at this closely, you see cos theta is the same thing as 1 minus theta raised to power 2 plus theta raised to power 4 minus theta raised to power 6, which you can see it's being reflected here. That's cos theta plus I. Now this is theta raised to power, this is theta minus theta raised to power 3 over 3 factorial. You see that for sine theta. That's sine theta. Now if you look closely, you see that e raised to power theta I now is the same thing as cos theta plus I sine theta. Now let's multiply through by r. If you multiply through by r, r e theta I is now the same thing as r into cos theta plus I sine theta. Now you see that this was what we got from our lessons when we taught how to express complex numbers in polar form. When we taught how to express complex number in polar form. So that conclusively, we can say that z is equals to r e raised to power theta I, which is the same thing as r cos theta, there's a bracket here, sorry, my pen, plus I sine theta. Now, so we can, which is also the same thing as a plus ib. Now this is, and which is the same thing as r in an angle theta. While when you express in exponential form, we talk in radians, and when we talk in polar form, we talk in degrees. Now, so that z can be expressed in, this is the exponential form, this is a rectangular form, and this also is our polar form. So that in our next lesson, we'll take some examples to help you understand it further. I'll ensure that these examples of this lesson comes up as fast as possible. In less than the next 6 hours. In less than the next 12 hours, I'll ensure you get this lesson. Thank you, and see you in our next class.